that Microsoft account. It kept on throwing me out. Uh, let's look at one or two examples before we go into what is called as differentiation. Okay. Uh, so let's just look at one very interesting example now. Just a second. So now, yeah, I think all set. Sorry, we wasted a few minutes. So let me run this thing. I'm going to I'm going to plot 4 functions, and I'm going to run that function, uh, and I hope you're able to see it. So there are 4 functions here. Okay. Now the 4 functions are. I hope you're able to see this. E power x, x cubed, log of x, and x power 0.5. Okay, these are the 4 functions. So you can see it in my screen here. Log of x, you can say that is e power x, first one, x cubed, log of x, x power 0.5. Okay, is that clear? Now, I want to find out the limit as x tends to infinity. Let's see what is the limit. For all 4, are you able to see my screen? I'm just showing it. On all 4, the can you see it? Hello?
Yes, yes, sir. Yes, sir.
On all
Yes, sir.
4, it is infinity. Okay. So as x tends to infinity, limit as x tends to infinity for all the functions, the value is infinity. The value of y, suppose I write it as y is equal to e power x, y is equal to x cube, y is equal to log of x, y is equal to x power 0.5. As x tends to infinity, all of them are infinity. So these are the corresponding codes. I just wrote it using the same chat GPT. Okay, that is the corresponding code. Clear? Now I'm going to you can try this out. I will send you this, but you can also try it out using chat GPT. Now I'm going to plot this. I plotted it. Let me plot it. So now if you plot it, this is how that the graph is. This blue, the blue one is log of x, the black one is x power 0.5, the red one is e power x, and this green one is x cubed. What do you see from this? Can someone answer? All of them going to infinity as x tends to uh, infinity. But what is that you see from this?
Different infinities. I don't.
There is only one infinity.
Yeah.
Infinity is, but say let me also change. If you have a doubt, uh, I can, if you want, I can change the the limit of plotting if you want. So I'll change the limit of plotting, say for example 10, so that, yeah. The problem is it's not. I think I'll get back to 3 itself so that it's more clear. Yeah, I think it's more clear if I'm going to plot it like this. So any comment on this? No comment? Look at it carefully. Look at it carefully. I'll give you, it's okay. I mean, even if it take 2-3 minutes, look at it carefully and comment on it.
Is it?
If you compare,
Yeah.
Yeah.
if you compare e power x and e power X formula. I think e power x rises slowly, but then it rises rapidly after
So,
that, whereas a green.
so, so I'm going to, so there is the green one, you know, is there's a small interesting problem. So let me increase it to 5 so that, just give me a second because this is not, where is that? Yeah, 5. I'm okay. Hmm. Yeah, I think that is, because this is the correct way. So I'm going to now look at this carefully now. So in 3, let me, I mean, I'm just shifting. You see this carefully. You see this carefully. Okay. I'm going to go back to 3. Okay. What do you think when you see this? There's someone who was answering. Please continue.
No,
If you see this, the green one seems to rise much rapidly than the red one.
Yeah. Okay. So let me just make it 5, or I mean, let me make it 5. Now what happens?
it looks like
Red rap.
yeah.
The red one seems to be faster. Okay.
Yeah.
So it has crossed the green one. Clear?
Yes.
So as x moves on, so let's put it as 7. Let's see what happens. Is that consistent? Yes, it is consistent. It is just racing ahead. Clear? Now, what we mean by this, what all of them reaches infinity, no doubt, but red seems to be racing ahead to infinity faster than the green. The only thing is I have to view it properly. But if I view it properly, it is very clear that exponential reaches infinity faster, followed by x power integers like x cubed, more than 1, followed by, okay, in order to do that, what is that followed by? I will just change it again to 3, then you will know it. That doesn't change. Followed by x power 0.5, followed by log x. So the moral of the story is that exponentials, ultimately exponentials reach faster. X power n next slower, x power 0.4, I mean less than 1, 0.5, 0.6 and all, still slower. Log, still slower. So the though all of them reach infinity, all of them reach infinity as x tends to 0, x tends to infinity, the rate at which it is racing ahead varies from one function to the other function. Is that clear?
Yes, sir.
So
Yes, sir.
so when you are looking at a function, it is not enough if you look at limit as x tends to infinity. You have to look at how fast uh, it is racing. It is racing. So why is this important? Let me get back to that picture. Let me put 7. Get back to my picture. Oh, sorry. Why is this important? This is important because when you model something, when you look at the result, okay, it is not enough if you look at only the limits at the end, because there is no such thing called infinity. There is no such thing called infinity. So what you have to look at is your range of x. Your range of x. It may so happen that in a particular application, okay, your x can be only 2, right? In which case, look at what happens. So initially, uh, e power x is high, then crosses over, then ultimately crosses over again. So there is a value of x, okay, beyond which e power x will gallop. But if you are looking at values which are very close to 0, then definitely we have to look at the graph before we decide which is bigger and which is smaller. Okay, so two lessons. One is the rate at which it is galloping is different for different functions, and which function will be galloping faster. E power x will gallop faster, but that doesn't mean e power x is always greater. It is always greater. It can so happen that initial values x power something may be greater, but after some time it would take over. Clear? Is that clear? So these are nuanced understanding of a function. Okay. Any questions? Do you understand this concept? Dr. Sundar is there? Yeah. Hello. Hello.
Yes, sir. Yeah.
Hello.
Yes,
am
sir,
I
you're audible, sir.
Yes,
You're
sir, you're
audible.
audible, sir. You're audible, sir.
Audible, sir.
do you understand this concept? You have to be okay.
Yes, sir.
How the functions behave. Right. Now we will go deeper into this function. I'm going to get out of this. I'm going to go to my so I'm going to get out of my system. I hope I won't have trouble. I'm going to go to my laptop. Sorry, I oh yeah. So great. I without problems I joined. Fantastic. So let me share my screen. Yeah.
Visible, sir.
It's okay. Visible.
Yes, sir, it's visible.
Yeah. Okay. We had looked at all this, and let us start. Give me a second. Let's start this differentiation. So what is differentiation? Remember, remember that we had a function. uh, we had many functions. We had plotted so many functions. I want you to look at that functions again and again. Okay. So isn't it? We plotted um, 1 by x, 1 by x squared. Okay. And then e power x, e power minus x. So many functions we plotted, right? Uh, and then we also found out the limit of these functions, and we came to a very important conclusion looking at those functions. What is that conclusion? Number one, we said that the rate at which a quantity, say y, increases is different for different at different places of a function. So suppose I write y is equal to some function, whatever be the function. Okay. So I'll just put y versus x, and I'm going to draw that function. I'm going to draw that. So now, remember that we talked about what is called as the slope. So at 2 points, we plotted what is called as the slope, isn't it? Remember that?
Yes,
So
sir.
what did we define as slope? Can someone tell that?
It's the rise over
Rate of change of the
change.
quantity y,
Yeah.
right? So this is what we said uh, is the slope. So actually, what did we do? What did we do? What we did was we we said that if, say, this is x1, this is x2, okay, when I move from x1 to x2, this is y1 correspond, and this is y2, okay. So the rate at which y varies, so is this, that is y2 minus y1. Clear? So when x2 varies from x1, it varies to x2, which means that this line is x2 minus x1. Y varies from y1 to y2. So so this line is y2 minus y1. So when I say change of x is equal to x2 minus x1, and the corresponding change of y is equal to y2 minus y1. So rate of change of y is equal to what? Can someone help me? Y2 minus y1
By
divided by
x2 minus x1.
x1. This is the rate of change of y. Now, I'm not happy with this because it the x seems to be varying a lot. When x1 becomes x2, x seems to be varying a lot. I'm not happy with this. So what I'm going to do is I'm going to reduce that. So let's see. I'll reduce it. Let it be like that. I will choose another color and now reduce the x2. Instead of going to x2, I will go up to x2 here, right? And then look at what is this now, y2. Okay. Now, so when I change this like this, then that is the change in y2, y1. So now the new one is this. This is my new y2 minus y1, and this is my new this is my new x2 minus x1, right?
But why you need to change it? Sir?
You have to change, pardon?
But why you need to change?
See, now this is my new y2, this is my new y2 at x2. My old y1 is x1, so I have, instead of going from here to here, I am going from here to here.
So
So
that is
this is,
X3 you need to say.
oh sorry, x3. Okay. No, I'm no, no, let me not confuse. So let me put it. So the new x2 is this point, right? The new x2. So now, so with the new, I'm writing the whole thing in black. So the new x2 is y2 minus y1 divided by new x2 minus x1. So this is now rate of change of y.
But the coordinates are different, no, sir.
I don't understand.
No, no, the coordinates of that red Y2 is different from the black Y2.
No, no, wait. I mean, let's understand this. So now I have, instead of going in the red from x1 to x2 and finding out how much y changes, which is this, y2 minus y1, I am going to go from x1 here to this point x2, okay? And I'm finding out how much y changes. That is, this much is the y change. So y2 minus y1 divided by x2 minus x1. Let's draw this. We'll take that alone and draw. So this is x1, this is x2, this is the y2. This is that's I'm drawing this triangle, y2, this is y1, and I'm going to write y2 minus y1 divided by x2 minus x1. So what is this value? This is a triangle, y2 minus y1 divided by x2 minus x1.
That is tan theta with your old
Exactly. So this is tan theta. Clear? So this is tan theta. Now you can see that as I keep changing this x2, the theta. Now let us now replot this. My red was like this. So that this was my x2 first. So this is my y1, this is my y2. So new triangle. This is the triangle. This triangle we are talking about. I'm just replotting that. So now this becomes y2 minus y1. Clear? So what is this theta? Now that is the theta. So the red one is tan theta is equal to y2 minus y1 divided by x2 minus x1. Clear? So this red theta is different from black theta. So if I now keep varying x2, when I now bring x2 closer to x1, my theta is going to vary. So what do I do? Let us now use the limit. So let me say that, let me now write down x2 minus x1 as delta x, y2 minus y1 as delta y. Clear? Let me write like that. Now, so the formula is delta y by delta x. That is the formula. Clear? In the black region, this is delta y, that is delta x. In the red, this is delta y, delta x are these things. Clear? Is that clear? Any questions?
Yes, sir. No. Sir.
Okay. Now, I want to bring x2 closer and closer and closer to x1. So in other words, if I now draw my graph, my function, if I choose this as x1, okay, instead of having x2s here or here, okay, I want to have x2 very, very close to x1. Very, very close. Okay. And then find out what is the increase in delta y. So how do I express it from the knowledge you have now? X2 becomes very, very close to x1. From the knowledge you have now. So what's happening to delta x? So x2 is going very, very close to x1. What happens to delta x?
It would be a very small number, like almost closing to 0.
So what is your language now? Mathematical language.
limit
Delta x tends to 0.
Limit as delta x tends to 0. Clear?
Yes.
Clear? So limit as delta x tends to 0, delta y by delta x. So this is instantaneous. At x2 itself, I am finding out what is the variation of y. It's instantaneous. This is what is called as dy by dx. So the slope, the instantaneous variation, the slope is called as the differential and is called dy by dx. Is that clear?
Even if the delta x is not tending to 0, could we say that?
No, even if delta x doesn't tend to 0, then I don't get the slope. So then we call this as a secant line. This line, say for example, I'm going to get this here. Then we call this as a secant line. So,
But
I'm not interested in that. I am interested in delta x tending to 0, delta y by delta x. This is what is my interest.
But I'm just curious, sir, if the denominator is 0, then the thing becomes what I
No,
say,
that is why we saw in
not a
limit.
definite.
So in limit, that is what we saw. That is why we studied limits. We saw in the limit that if the numerator, there's a numerator and the denominator, when the denominator goes to 0, it doesn't mean the function delta y by delta x goes to 0. Remember that. So this is what we said. When that limit as delta x, so many examples we saw. Jason, you remember that?
Yes, sir. Yeah. So
So many times the denominator seems to be going to
0, but it's not. Yeah.
But does that limit of that whole function, does it go to 0?
No.
No.
Yeah.
Right? So
Yeah.
that is the beauty of that limit. That's why we studied the limit.
Sir, in this case, does the secant becomes tangent?
Yeah, secant, as it's called secant line. It's not
Yeah.
secant, it's called secant line.
Yeah.
Okay. But ultimately we are interested in still that angle theta is theta and the ratio is still the tangent of that theta. But I want this theta to be calculated, okay, as I go closer and closer to x1, so that delta x now, okay, becomes small. So the beauty of it is that's why we studied limit. Limit as delta x tends to 0, a function does not become
Undefined or something. Yeah.
undefined. It doesn't become. And sometimes it becomes. We are going to see when it becomes. So
So
dy
could it be
by
vice versa? Like whenever it doesn't become 0, we call it as a differential function?
no, wait. Let me limit as delta y by delta x. Now, what is delta y? Let me define this function more carefully. Okay. Let us say that this is the x1 value. So I add a small number, x1 plus delta x. Okay. So I can write this as limit as delta x tends to 0. Up to this is fine. What is delta y? Delta y, look at this, is this function calculated at x1 plus delta x minus this function calculated at x1 divided by delta x. This function is what I called as y. So I will write this is limit as delta x tends to 0. Y value at x1 plus delta x minus y value at x1 divided by delta x. So there's a numerator and denominator. So delta x tends to 0 does not mean that it is going to go to 0. Is that clear?
Yes, sir.
Is that clear? Now, in order to, you can put various functions, and there are a list of things that I'm not going to derive that. I'm not going to derive it. Right. So let us say, let us look at this. Let us look at this function. Function y is equal to x. This is the function, right? So just y is equal to x. What is this y is equal to x? We saw that before. How do you draw y is equal to x?
Straight line through the
Straight, straight
through
line
the zero through zero.
through zero. What is the angle of that?
45 degree.
45 degree. Brilliant. Jason, is that you who's answering?
Yeah. Yes, sir.
Brilliant. So you really remember, I'm very happy you're now. Let us now substitute this in this expression. What do you get? Let us take this point, okay, x1, and let's take delta x, and I'm going to make delta x. This is x1 plus delta x. I'm going to make delta x go to 0. Okay, so I get y1 here, and I get y2 here. Okay, so what will be this? What will be that? This is delta y. What is, can you comment something on delta y with respect to delta x?
It would be same.
It will be same because x1 is equal to y1.
Yes.
X1 plus delta x is equal to y2. So y2 minus y1, which is delta y, is the same as delta x. Clear?
Yes, sir.
So limit as delta x tends to 0, delta y by delta x. Okay. How do I write this? What is this? What is delta y? Because it is a straight line where every point x1 is equal to y1, x1 plus delta x is equal to y1 plus delta y, which is equal to the same as x1 plus delta x. So how can I write this? I can write
1
this as delta x by
x by
delta.
delta. Yeah.
Okay. So limit as delta x tends to 0, delta x by delta x is what? 1. Clear?
Yes, sir.
So though delta x looks like delta x tends to 0, I'm going to have trouble. This function numerator by denominator helped me. So the lesson which we learned earlier, that I can't look at only the numerator and you have to look at numerator by denominator, is very, very important. Is that clear?
Yes, sir.
Others who are all there? Dr. Sundar is there?
Here, the Shanti Jiraj.
Dr. Shanti is there? Dr. Shanti, is this clear?
Yeah, yeah, it's clear.
It's clear. So this is what is dy by dx, right? So what we have essentially done is we have written this function y is equal to some function of x. Okay, this is the function. So we have now know what is dy by dx. This we know. Okay, what we understand. One thing we understand is that dy by dx may or may not be the same at various points. May or may not be the same at various points. So there are very interesting things with respect to this. I'm not going to derive for every function. Our MATLAB is there, so I'm not going to derive for every function. So before we go and further see where this differentiation exists, let us look at a few examples in MATLAB. Okay, so I'm going to stop this and I'm going to go back to my MATLAB session, okay, and show you a few examples before we come back to more theory. Okay, I'll just share my screen. You able to see my
Visible.
screen?
Yes, sir.
Visible?
We are able to see it.
Yeah. So let us now look at certain examples. Let us see, and then we will go to our chat GPT like before. Okay. Now, uh, 1 minute. What I'll have to go to that my set function. Oh, wait, sorry. Yeah. Okay. Now let us look at this function. See, look at this. F is equal to 1 by x. I wrote this using chat GPT, nothing more. Okay. Now, how do I write? Let's look at the simple, you don't need to remember anything. You don't need to remember anything. Let me go to the first one. So you need not remember anything. So the command is very simple. Now I'm going to have a function ax squared plus bx plus c. This is the function I'm going to have. I'm going to ask MATLAB, okay, to differentiate this function and display what is df. That's all I'm going to do. Right? So this is symbolic operator. That means I'm not going to give a value for a, b, c, x, and so on. It is a symbolic representation of the function. So the command is df is equal to diff of f comma x. That means differentiate the function f, okay, with respect to x. What is with respect to x? The delta x that is in the denominator is x. We will see later it can be more than one, but right now I'm going to differentiate f with respect to x because I've written it as ax squared. Is that clear? Okay, let's see what it is. Simple. It is b plus 2ax. So this is the differentiated so I'm getting a new function. What is this new function? Let's now plot for a function. Let's take a function is 1 by x. I'm going to make it more difficult. Let's say make 1 by x. I'm going to differentiate this function. Okay. Diff f comma x. I'm going to now plot this function and its derivative. Look at that. Look at that function. So the function is in blue. The function is in blue. Clear? The function is in blue. Its derivative at various points is plotted in red. So point number one, as you vary x, its derivative varies. Okay. What are the other things that you see from this graph? What are the other things you see from this graph? For this function 1 by x. First an intuition, and then look at that red and tell me.
At higher values, it tends to.
Derivative becomes constant.
Almost zero. It becomes
Yeah.
almost zero. Yeah.
Zero.
So when does it become zero? Look at that blue graph and tell me.
When x tends to 15.
No. Look at that more carefully. Not the value of x. Look at that graph more carefully. The blue graph.
And
No. You see that the blue graph becomes flatter.
yes,
In this region, it becomes flatter. The derivative is going to zero. It becomes
True.
flat. Okay, the derivative goes to zero. Why?
because there's no variation.
No variation. So from that formula, that's very good English answer. But from that formula,
Delta y
Can
is
be
0.
1 by infinity. So it will be 1 by
no,
infinity will be 0.
no. Wait.
Delta y would be 0
Zero.
for.
Delta y is actually not zero, becoming smaller and smaller and smaller.
Smaller. Yeah.
Okay, smaller and smaller and smaller. So when delta y becomes smaller and smaller and smaller, delta y by delta x is become smaller and smaller and smaller. Clear? So
Yes.
the flatter the curve, the slope approaches zero. It's approaching zero. Now, that's point number one. Is that clear?
Yes, sir.
Any questions? Others? Any questions? It becomes flatter. Okay. So all these graphs, all these functions are the ones you are going to see in your profession. I'm just going back to teach some theory. In fact, I read somewhere that 3 functions most important in medicine: e power x power 1 by x, or 1 plus x power 1 by x, log x. These are important functions. So what we have seen are all important functions, and its derivative is very important for you to take a decision. That's why we are looking at derivative. The next point, what is the next point that you see? What is the next point you see? Carefully look at the red graph, the derivative graph. Look at that graph. What do you see?
Initially very high slope.
No, very high or very low? No, look at that carefully.
Oh, negative.
Negative. So the next point is that the whole region where we are, the whole of the region, the derivative is what? Negative.
Negative.
Why is this negative? What does it mean by negative? Go back to my function delta y by delta x. Why is it negative? Why is it negative?
So y is decreasing, sir.
Decreasing.
Y is decreasing. So as I change from here to here, delta x, as I change from this position to this position, my y has come down. And my formula is y2 minus y1. So delta y is now negative. Decreasing means what? Y2 is less than y1, y3 is less than y2, and so on. So it is decreasing. Y is decreasing. So delta y becomes negative. Is that clear? So when the slope is negative, then the function is decreasing. The more negative it is, the faster the function is decreasing. The less negative it is, the slower the function is decreasing. Clear?
Yes, sir.
Yes, sir.
Is that clear for everyone? So it's the same thing with positive. Suppose it is the opposite side. Then this can be positive. The same graph. It can be positive. Any questions? Is that interpretation is clear? Okay. Yeah. Again, don't worry about this ChatGPT. I just cut and pasted it. Okay. Now I can calculate, for your sake, I calculated slope at 5, x equal to 5, and I calculated the slope at x is equal to 10. You see that it is more closer to 0 as x keeps increasing, right? Now, let us now define this function again, what we did before. Now I'm going to put 4x squared plus 3x plus 2. I'm going to differentiate this. What is this function, this kind of function called as? X squared term is there.
Quadratic.
We call this as quadratic function. Quadratic. Okay. X is equal to if x cubed Then what if this 2 is 3? What will you call that? Cubic.
Cubic.
Cubic. Okay. Generally, it is a polynomial equation. Again, very important for you guys. So I'm going to take examples after I finish some theory. Now I'm going to differentiate it and draw the derivative. Yeah. So the blue is the function and red is its derivative. So what is your comment?
The slope is constant.
Number one, the slope is constant. Okay. The slope is constant. So why is it constant? We'll come to that because of the formula. Okay, we'll come to that. One. So slope is a function of function of 4x squared plus 2 plus what is that? 3x plus 2 derivative of it. So the derivative of that makes the slope constant, not the value constant, slope constant. Is that clear?
Yes.
Number one. That is not. So look at that again. Number two, more closely. Our red and blue, more closely. Look at that red and make a comment.
They intersect at one point.
Okay, that's not important because both of them are different. Yes, it intersects at one point, but there is very interesting stuff there. What is it? It varies. The red now, look at that, varies from minus to plus. Minus to plus. Do you see that? It starts nearly at -5, at -1, and then at 1, it is nearly 11. Clear? Is the graph clear? Look at that. So these are all minus. Okay. And then it becomes plus. Now, minus and plus. Now look at this blue line, which is the function, and look at this red and make a comment about when it is going from minus to plus. We saw that before. What? We saw that.
It becomes plus when the graph starts rising, like when the slope's increasing.
Exactly.
And by 2
No,
becomes more than by 1.
Yeah. Yeah, sure. Hello. Dr. Shanti, is this clear? It varies from minus to plus. Okay. So when is this minus? So it crosses 0. When is this minus? We saw when it is minus when the function is going down. Right? And when can it be plus? When the function is going up.
Yes.
And so it should, so you see this minus, then it goes up and becomes plus. So somewhere it crosses the 0. That's where it crosses 0. Clear?
Yes.
It's clear.
So what can you comment about that point 0? Now that you know this side is decreasing, this side is increasing. So the slope is horizontal. That's what it means. First of all, 0. Okay, that's what we saw. Delta y will not change. But what does it mean exactly when dy by dx is equal to 0? The red line is dy by dx.
so x is equal to 1.
No. When what is meant by dy by dx? How do you interpret this blue graph or blue function? It is the transition. It comes down and then goes up. at 0, the slope is equal to 0, comes down and goes up. So what should be the value of blue when it is 0?
Constant or like flat line.
Flat line is, yeah, that is the derivative is flat, horizontal.
The function
is
should
it?
be constant, like the value of the function should be
The function is not a constant. Function is varying. That blue line is the function.
Sir, is it the straight portion of the blue line? If you could, there is a portion of the blue line which is straight.
No, it is not straight at all. It's the curve because of the way you see the screen. It's a curve. It's a curve like this. Okay. So now the two things we saw. When the curve is coming down, the slope is negative. When the curve is going up, the slope is positive. So what can be the point when the slope is equal to 0?
Just when it goes up.
No, just when it starts going up.
Mm.
Clear? When
Yes.
it just starts going up. Because below that, if you go, it's going to raise in the other direction. Right? So it's coming like this. And so it is negative as it is coming, positive when it is going. So what happens at 0? Think a bit. The slope is horizontal. So the blue assumes the minimum value there because it's coming down. At one point, it's going to raise. Clear? That point at which it starts raising is neither here nor there. So that is the lowest point. So when dy by dx is equal to 0, the curve attains the lowest point. Not only minimum point, it can be just the opposite side. If we'll see that again in another example. Blues, not now, but blues like this. Okay, then this will be in the other direction. Again, it will go to 0. I'll show that in iPad. So again, you will get a maximum value. So when dy by dx is equal to 0, the curve, which is blue here, can get a minimum value or a maximum value. Is that clear?
Yes, sir.
So actually, a doubt, sir.
Yeah.
So when you're saying that it's a minimum value, does it mean it's the minimum of the entire function, or
Of
because if
this
you have
function.
an oscillating function, if you have an
Exactly. We'll
oscillating
come to
function,
that. That's a very good question. We'll come to that.
oh,
Okay. So this function gives you what is called as a global minimum. Beautiful question. Very important question. Give me 2 minutes. Right. So what?
okay.
That's Arjun, right? Or Anson? Who's asking that question?
Arjun.
Arjun. So what
Yes.
Arjun is asking is, will this, if I now move from 1 away from 1, say I put 100, will I still have this to be minimum, or will there be another minimum? Will the curve go decrease, increase, and so on? Okay. Okay. So for this curve, we're going to have examples like that. For this curve, it so happens, or it is this curve I've chosen has only one minimum, which means that globally, this is minimum. Clear?
Yes.
Okay. Now, will this, let's look at another function. Is that clear, Arjun? We'll come to that.
Yes, sir.
Yeah. Now, let's look at another function. I heap power x. So just give me a second, which is I have to go in an order. Okay. Now I'm going to, this is the function. What is the function? Y is equal to e power x. Okay. Here is it. I'll pass this on, but you try it with ChatGPT. So y is equal to e power x, right? I'm going to ask MATLAB to plot e power x and also its derivative, that is dy by dx. Plot that also. Calculate the derivative values. Okay. So that is what I wanted to plot. Now, both values, y is equal to e power x and its derivative of e power x, both of them are the same. So the slope is just e power x for this. Clear? It's a function. So why? Let's not go into deriving it. That's not our idea. Just learn that e power x, the derivative of e power x is also e power x. Period. There is no, now you ask me where is minimum? No, this function does not have minimum. It just keeps on increasing. Because it infinity, its limit as x tends to infinity, y tends to infinity. So as x keeps increasing, y keeps on increasing. It doesn't hit a nadir. It doesn't come down and then go up. So that's why slope is e power x. Both of them are the same. Clear? So whether there is a minimum or a maximum depends upon the function. Sometimes this need not have a minimum at all. Sometimes it can have a minimum. It can have more than one minimum and so on. Okay. Now let's just look at this function. What is that? Yeah. Let's now plot for a sphere. The sphere becomes very important because many tumors are all spherical. Okay. So let us plot this. The blue line is the surface area with volume. So as volume increases, the surface area increases. The surface area increases. Right? But it increases very interesting fashion. Yes, of course it will increase. It is increasing. But what is the rate of increase of surface area? This becomes very important sometimes in diffusion. So you will see that the rate at which the surface area increasing is coming down. Is coming down. Though the volume is increasing, the rate of surface area is coming down. Okay, so derivative gives me the physics behind that curve. I'm able to understand what's happening. So in other words, slopes are different. If it are different at different points, gives me a good idea as to how this function behaves. Is that clear? Any questions? Now, let us look at whether all functions have derivative or what happens. Right. So I'm going to close this. I'm going to go back to my, sorry to go up and down. I will, oh, what's happening?
So in the last equation, you talked about tumor volume, no, sir?
Yeah.
In that, does that apply for any spherical thing or
Yeah.
just
No,
any
if I change the volume, okay, and then I saw that how the surface area varies.
Okay.
So that becomes very important for many applications. So I said that the rate of increase of surface area is different uh, for different volumes.
Okay.
Clear?
Yeah.
Okay. Now let's look at when does this derivative. I mean, we can derive what I showed you now. I can derive it. Uh, let me postpone it a bit before we start, because deriving means is a bit difficult. Now it gets into some difficulty. So I will do that maybe later. Let us look at something more interesting things right now. So let's now look at this. There are 4 curves. Okay, there are 4 curves. Curve A, curve B, curve C, curve D. Right. So now there's a black line and a blue line. You're able to see this? Is it clear? There's a black line and a blue line. One of them is the function, and the other is the derivative. Now, can you recognize that? So in this black and blue, which is the function and which is the derivative?
Black is the function and blue is the derivative.
Blue is the derivative. Why?
Because the first equation, the slope is constant, and so the constant number.
So wherever I go, this is that angle theta. Remember? Tan theta. That is the same. Is that clear?
Yes.
So the slope is a constant. So what is this line? This is a straight line. So this is y is equal to some whatever slope. So mx plus c.
Plus
That is a function. Okay. So when I derive this, so m is the slope. So dy by dx becomes m. That's all. In this case, what happens?
It's the same equation we just saw before, the quadratic equation. So the
Quadratic.
slope.
Fantastic. So this is the slope.
Yeah.
Now, look at this. This is what Arjun asked. There is, which is the function? Black.
Black is the function and blue is the
Blue is the
Now
derivative.
look at this. So it is increasing. The function is increasing. So what is happening to the slope? Which is increasing, and then hitting a plateau. What is increasing? What is happening to the slope at every point? Function is increasing. So the point number 1. So what will the slope be, positive or negative?
Be positive.
positive.
It is positive. So you can see that they're all positive, right? The whole thing is positive. Now, so the other thing you see, how is this? The slope is coming down, right? And this function then takes one turn there. what does it do? It reaches a maximum and starts going down. Clear?
Yes,
It reaches a maximum and going down. So how will my derivative behave?
It becomes 0.
Cross 0 and go into negative.
It has to be negative, going down,
Yeah.
delta.
Down.
So what happens at this point? It is 0 because it has to change sign. When it is racing, my slope is positive. When it is coming down, my slope is negative. So at one point it has to cross. So that's what it is. Clear? That's the
Yes,
point.
sir.
The other way. It is coming down. And then it's coming down now. At one point it starts going up. What will happen to my slope?
Slope will become positive. Cross the line and becomes positive. Yeah.
So again, what will be there at that point? It will be
0.
0. So whether it is reaches a maximum or whether reaches a minimum in this neighborhood, it is 0. Now, how do I find out whether it's maximum or a minimum? We'll do that in the next class, not now. But let us at least understand now that it can be a maximum, then goes to minimum. Clear? So the
Yes,
same thing. So Arjun, now you understand that it is not necessary that there can only be one minimum. There can be more than one minimum.
Yes, sir. Yes.
Okay, same way, more than one maximum. So for example, this curve has two maximums. There can be a maximum and a minimum. Now, this is very important further on when you do machine learning, AI/ML, and all those things, that the function need not have a beautiful 0 like this, the gradient like 0, or minimum like this, which means that this function is very well behaved. Nice guy. So globally, there is only one minimum. So if I want to find out what is the minimum for this, okay, then I can very easily do it. Just find out where the slope is equal to 0, period, over. Clear? Now,
Yes.
if you ask me, if I give you this function, let me clear all this. If I now give you this black function, the function is something like this. And I'm going to ask you a question. Where will it be minimum? Okay. Then it is the slope does not give you that. The slope only becomes 0. Say, for example, this is a better example. So I'm going to ask you, where is this maximum? Not very easy to find out if I don't plot that black one. I can't just find out from the slope. See, here it is. Here there is. It may be here, or it may be here. Okay, and so on. And there are locally there are positive. I don't know how this black will go on further. The black further on may go like this. So there are a number of local maximas, number of local minimas. This curve, this lovely curve here, which makes our life simple. It is okay. It is convex. It is called convex. Coupling, convex. So convex functions are nice guys. They are very well behaved guys. And if I want to find out the minimum of a convex function, very simple. I have to now look at where the slope is equal to 0, period. I need not calculate every value throughout. I just have that convex function. It's a nice convex function. I just find out the slope is equal to 0, finished. Over. Okay. So these convex functions are well-behaved functions. And when I say I want to calculate the minimum, what we are saying is that we are going to optimization. We are going to go into the realm of what is called optimization. When I say minimum, what is the minimum value or what is the maximum value? Okay, this is an optimization problem. On the other hand, these guys are not so nice guys. Unfortunately, in many machine learning problems, you will face these guys quite often. So we have to have special methods to find out this kind of minimums. Is that clear?
Yes.
Okay. Now I can keep. I will go into practical examples later, but there are some, I would say, simple things, that simple formula which I'll give. No need to remember anything. You have your chat GPT, just go and plug it into chat GPT, ask it, or you can ask, put it in MATLAB. So yeah, so there are just four things, for four functions I'm going to say. So many times the function can be written as y is equal to some function of x. This is how you write a function, right? Now, dy by dx is also written as y prime. When I say y prime, it also means dy by dx. Is that clear? So let us have a function which is, say, y is equal to constant 4, which means that's the line 4. Okay, independent of x. So then, what is y prime? Whatever will be the value of x, it is 4. So what is y prime, which is dy by dx? It doesn't
Zero.
change.
Zero.
Zero. That's all. If I have a function of x to be x power n, I'm just going to write down the function, the value. Then this is y. Then y prime is n x power n minus 1. As you get used to it, you will get, very easily. This is so when I have my function is equal to e power x, then y prime is equal to e power x. So give an example here. So x power 3. What is x power 3? Yeah, what is n? N is equal to 3.
3.
So what is the derivative of this? 3x
X square.
Y prime. Okay. So let us say I have two functions, function x and g of x, two functions. Then, so if I now want to find out what is its derivative, then I'll put one line there, or d by dx of this function plus this function. So the derivative is independent derivatives of each function, and I'll add. So what do I mean by this? Let's understand this. So suppose I say that function x is equal to x squared. Another function, which I'm calling it as g, is equal to x. So I want to find out what is the derivative, which I'll write it as d by dx, get used to this, of these two functions added together, which means that it is a derivative of x squared plus x. So we derive each one of them separately. So what is for x squared? Look at that formula, n x power n minus 1.
2x.
So 2x
X.
plus for x 1. Okay? Because x power 1, x power 1 into x power 0, that becomes 1. Clear? Is that clear?
Yes, sir.
But don't worry about remembering everything. We have a chat GPT, we can easily do that. Oh, suppose I have a function, suppose 2x squared. So instead of function x is equal to x squared, I now have a new function, which is 2x squared. And I know for this function, which is y prime or for f prime, whatever it is, when I put prime, it is derivative. What is this? 2x. Right? So
Yes, sir.
the derivative of this function is nothing but this 2 is remains there into 2x. So in other words, if I have a function and I multiply by a constant c and get a new function, then y prime is the same constant multiplied by the derivative of this function. So derivative of this multiplied by constant c. Is that clear?
Yes.
Okay. Then just one more rule we see it, and then we'll close for today. Sorry that there was a small thing, this which is multiplication. So we'll see division. So I have a function which is fx and another function gx. Let us say function x is equal to x squared minus 4. So another function of x, another function of x, so which is 3x plus 1. So that, let's say I have two functions. So now I am forming a new function, which is multiplication of this function. What is that? Which is x squared minus 4 into 3x plus 1. I'm forming a new function by multiplying them. Clear? So now I want to take the derivative of the new function. Clear? Of the new function. So the derivative of the new function, which I would call as p prime x, is equal to, which is dp by dx, is equal to the first function fx multiplied by the derivative of the second function plus the derivative of the first function multiplied by the second function. This is the formula. 3-4 formulas you may have to remember. We'll do some examples, then you will understand. So what does this mean? We will see that in the next class, how to apply to this. Right? We will see that and apply it to in the next class and understand this derivative. So we understand the physics behind it, a few examples. Don't worry, more than that, we are not going to go. We'll go to MATLAB, whatever be your complex function, put it in the MATLAB, and that gives you the result. That gives you both the curve as well as its derivative in order that we understand. Is that clear? Any questions? Okay. If there are no questions, we'll stop here. And we'll continue in the next class. Any questions, please ask me. If there is anything, next class we will give a good revision. Meanwhile, please see all the recorded ones. Be familiar with it's really fun to use ChatGPT. Any damn thing you can ask. It gives all the answers. Some of them may not be correct because if you make a mistake, the small things that you may have to know some. After I go through some classes using ChatGPT, we will go and debug or rather understand the MATLAB code itself. We will take some time. Don't worry about it. But right now, I'm going to use ChatGPT to write. Next class, I'm going to do a series of problems, all using ChatGPT to generate MATLAB code, cut and paste it, and see how it works. I'm going to do that from next class. Okay?
Okay.
Yeah.
Thank you very much.
Thank you,
Thank
sir.
you.
Thank you.
Thank you, sir.
Yeah, thanks.